Welcome back to Pleopod, the show that explores the cutting edge of technology. Today, we're looking up, way up, to the final frontier for data centers. Maya, the demand for AI computation is exploding, but our ground-based infrastructure seems to be hitting some serious limits.
Absolutely, Arman. It's a bottleneck across the board. We're talking about grid capacity issues and incredibly long permitting timelines. Grid interconnection for new data centers can stretch up to 7 to 10 years in major terrestrial markets. That's a huge hurdle when you need to scale compute power rapidly for AI.
7 to 10 years. That's practically an eternity in tech time. And it's not just power, right? Cooling is another massive challenge, especially with the water scarcity concerns in many regions.
Exactly. Data centers consume vast amounts of water for cooling. So if we can't build them fast enough on the ground, and cooling is becoming a major environmental and logistical issue, what's the next logical step? Some are looking to space.
Orbital data centers. It sounds like science fiction, but it's a real area of development. What's the fundamental advantage of putting data centers in orbit?
There are a couple of big ones. First, power. In orbit, solar panels can be up to 8 times more energy efficient per square meter than those on Earth, precisely because there's no atmosphere to absorb or scatter sunlight. Think of near continuous power from the sun.
8 times more efficient? Wow. And the cooling aspect?
That's the other key advantage. Space is a vacuum. This allows for radiative cooling, where heat can be dissipated directly into the cold void of space. This means you can get rid of the need for those water-intensive cooling systems that are such a headache on Earth. Radiative cooling in space is incredibly effective.
So you get abundant, efficient power and a natural cooling system. It sounds almost too good to be true. Are companies actually doing this now?
They are starting to. Companies like StarCloud are leading the charge. They actually became the first company to train an LLM in space back in 2025. That's a pretty significant milestone. They've also raised substantial funding, like a $170 million Series A in 2026, reaching a $1.1 billion valuation.
So not just vaporware, there's real investment and real progress. What about other players?
We're seeing a broader trend. Cowboy Space Corporation, formerly Aetherflux, has ambitious plans to deploy a constellation of 20,000 satellites for data center operations. And it's not just startups. Major tech giants like SpaceX, Blue Origin, and Google are also exploring space-based compute infrastructure. They see the potential.
20,000 satellites. That's a whole new orbital ecosystem. But it can't be all smooth sailing. What are the biggest challenges these companies face?
Oh, there are significant hurdles. Launch costs are still very high, even with reusable rockets. Then there's the harshness of space itself. Space-based data centers face significant challenges, including space radiation, which can corrupt data and degrade hardware over time. Longevity of equipment is a big question.
Radiation is a serious concern for electronics. And what about getting the data back down to Earth reliably and quickly?
Data transmission is another challenge. You need robust, high-bandwidth links. And then there's orbital debris management, a growing problem as we put more stuff into orbit. Plus, the regulatory landscape for operating these massive constellations is still evolving.
It sounds like a monumental engineering and logistical undertaking. For now, are these orbital data centers envisioned for massive AI training or more for specific tasks?
It's fascinating to think that the next big leap in AI might be powered not by earthbound silicon, but by hardware floating above our heads. It really underscores how critical infrastructure is and how innovation finds a way around limitations.
Definitely. It's a bold vision, pushing the boundaries of what's possible. The economics still need to fully shake out, and the technical challenges are immense. But the driving forces, the insatiable demand for AI compute, and the limitations of terrestrial infrastructure are very real.
A truly timely topic, Maya. We've covered a lot today. For our listeners interested in the future of compute and space technology, this is definitely a space to watch. Thanks for breaking it down for us.
My pleasure, Arman. It's an exciting space, literally.
And that's all the time we have for this episode of Pleopod. Join us next time as we explore another frontier in technology. Goodbye for now.